This is the Nature of Science Common Assessment podcast to help you get ready for the Nature of Science Common Assessment coming up this week. To start off with, I want to talk about how to use this podcast. Since this one covers so many different chapters, I've actually organized it slightly differently. First of all, of course, with all podcasts, pause it and answer as many questions as you can before going forward. Try to fill out as much of your study guide before listening to the podcast. Next, watch the video and check your answers. While you're doing that, correct those mistakes you may have made on there, as well as add to your answers that need more stuff added to them. Also on this podcast, I've put the page numbers up in the upper right hand corner, so look for that up there. If you have more questions, you can flip to that page and it actually has more information in your textbook. Also on the left hand side, you can see that I've marked the sections, so that way you can find all the sections that this information is coming out of as well. That also matches up with your study guide that you already have. Finally, pause this video as you go along. Stop it, write things down, quiz yourself on it, and then go back and watch it again. Of course, also you can watch this a couple of times. That's the nice part about this compared to me actually presenting in class. You can watch and rewind and fast forward through the parts that you already know. Some other tips I want to give you for how to study, especially for a major test, but this applies even to the quizzes you take in any class. First of all, study early and study often. That actually helps you out quite a bit. You can actually even study less time if you start studying earlier rather than trying to cram it all at the last minute. You'll be able to remember it much better, and it'll make your life just much easier. Look at what investigations you did during this section. Investigations come into play with the different things that we're covering, and you'll start to see this even more so as we move into the actual content section instead of just looking at the nature of science. Review the words in your glossary. Even though there may not be a listing of all the words that are on the test, they're still fair game and they can show up on the quiz or test, so you want to look over those as well. Try the practice questions, especially the practice questions posted on My Big Campus, as well as ask questions on My Big Campus and in class. You come down and see your teacher during charger time, or ask them questions on My Big Campus and try to figure out what you need to figure out. Okay, it's important to ask questions whenever you're confused about something so that we can actually help you out. Finally, and probably most importantly, you want to study with someone, either a parent or a friend, or a sibling, or anybody that really can help you to study. And this will help you a lot because you'll be able to actually go through this information with someone else. So now let's move on to the actual materials for this quiz or this test. First of all, the first thing on the study guide is what is the difference between qualitative observations and a quantitative observation. Taking a look at it, we have qualitative observations, which are descriptions or labels, while quantitative observations are numbers or amounts. When we actually break that down, the easy way to remember is to remember that qualitative has an L in it, that means it has labels, while quantitative has an N in it, which means numbers or amounts. That's a way to remember which one is which, looking at the letters in there. Let's practice with an example here. I put a picture up on the screen, and you can see on here there's a whole bunch of different gumballs. And if we take a look at it for a qualitative one, we can see that there are blue, green, red, yellow, pink, and white gumballs. Well, if we look for a quantitative observation, that's one with numbers, we can see that there are 3 blue gumballs in the picture. Moving on to the next topic, what does it mean to infer? Inferring is based on reasoning from what you already know. So an inference is based on reasoning from things you've already experienced in life. It's basically interpreting an observation to make an explanation. So if you're explaining what's going on but you didn't actually observe it, that's actually an inference. The next topic is give an example or be able to use deductive reasoning to come to a scientific conclusion. So using an example, you have to figure out what deductive reasoning is, which is a way to explain things by starting with a general idea and then applying the idea to a specific observation. So you start with something broad that you already know and then apply it to something more specific. An example we have here is all squares are rectangles and rectangles have 4 sides. So therefore, squares, which we've already defined as rectangles, must have 4 sides. It's basically using that logic to say, hey, if I have one thing that this is the case every single time, then this situation has to be the same thing. The next topic is given a scenario, describe the bias in the experiment. And so we'll start out with looking at what bias is, which is a mistake, like dislike, or anything that influences the results of a person's behavior or an experiment. So it's anything that causes an influence, whether planned or unplanned. An example is, let's find the average age of the student at Carroll Middle School. And if we're going through doing that, I would say, well, I'm just going to ask all the students in Team Lightning. And I might have a little bit of a bias there on that experiment, because if I ask only the students in Team Lightning, I've actually now ignored the 7th and 8th grade, so my results are going to be biased. I may say that the average age of the student at Carroll Middle School is 12, when in reality it's probably closer to 13 because we have 6th, 7th, and 8th grade students. And so that's an important thing to make sure, is that you actually are looking at the correct amount of stuff. There are other examples of it, but you have to think about, does this really have an influence on my experiment? There are some things that may have absolutely no influence, and they wouldn't then qualify as a bias. For example, it may not be a bias what color of paper we write the question on or something like that. That may not cause a bias unless we're studying how that paper reacts to something. The next thing is, what is the difference between independent variables and dependent variables? We take a look at it. We'll start out with independent variable, which is a variable that is purposely changed, while a dependent variable is a factor that may change in response to the independent variable. We can take a look here then to kind of sum it up. Independent things we change, while dependent variables are things changed because of other variables. You may have heard the term before that you are actually considered a dependent on your parents. And a way you can think about that is, if your parents decide to move, you have to move as well. You depend on where they're at for where you're going to be. So your parents are independent, can choose to move, while you're dependent, you have to move when they move. That's just one example, and there's lots of other examples that you can think of as well. The next thing is, how should you control variables in an experiment? Specific ways to control a variable in an experiment is actually through what's called a controlled experiment. This is when you change only one variable at a time. And this is a very important experiment we do in science, and it's one of the most common experiments that scientists use. And what we do is we take the independent variable, which we already talked about, is the one where we purposely can change it, and then measure how it changes. To figure out what variable you change, you always want to think about, what is it you want to study or see the effect of. For example, if you want to see what happens when you increase the temperature on your thermostat, you would then increase the temperature. That's your independent variable. Your dependent variable would then be your furnace turning on and then the house warming up. That's just one example of a controlled experiment you could do where you change your independent variable and see its effect on the dependent variable. You're also going to be asked to pick out the variables in different experiments. There'll actually be some story problems, and as you read through them, you're going to have to identify the independent and dependent variable. We've already gone through this definition a couple times, but I'm going to go through it one last time. An independent variable is one thing that we change on purpose. So we actually are changing this setting. It's actually a lever we physically move, or it's something we add to it. Those are independent variables. A dependent variable is one thing that changes because of what we change. Or we can also think of it as being what we measure, or even the result could also be considered the dependent variable. And so those are important things to make sure you can identify. Controlled experiments do show up quite a bit on this common assessment, so you want to make sure you spend some time looking over them. The next thing we're going to move on to is the unit system. And specifically, the first thing is you need to be able to convert between units. We'll take a look at a table similar to what's actually on the test, and you can see on here it has the prefix, the symbol, as well as the multiple listed there. And you can go through and see how we need to change it. So for example, a kilo means we have 1,000 of the single unit, or the one that has no prefix in front of it. So a kilometer has 1,000 meters in it. Now, let's look at an example here. We have 100 kilometers. How many meters are inside that, or inside those 100 kilometers? When we start out, we write out the 100, and we know that we're going from a number that says that there's going to be 1,000 down to one that has 1, so we need to move the decimal place to the right. And so we're going to end up having to move it over 3 times because we have 3 zeros there. And so we go over 1, 2, 3, and we find out it's 100,000 meters in 1 kilometer. We could also just multiply the 1,000 by 100, and we get the exact same answer. Moving on, you also need to be able to convert between some other units. So for example, we have 5 kilograms, and we need to figure out how many hectograms. You can see I made a mistake here, and I already had 0.5 hectograms on there. But if we take a look at it here, we can see we start with 5, and we're going from hectograms to kilograms, so we are moving up on the list, so we have to move the decimal point to the left. We move it over one time to the left, and we find out then that it is 0.5 hectograms. The next thing is you need to know how do you find the density of an object. We'll start out with you need to know this equation. This is very important. Density equals mass over volume. This equation, you just need to memorize it. You're going to use this 6th grade, 7th grade, 8th grade, 9th grade, 10th grade, 11th grade, and 12th grade, so you might as well get it out of the way now. It's an easy equation to remember. D equals M over V. So let's look at an example here. What is the density of a liquid with a mass of 15 grams and a volume of 10 milliliters? So we write out our equation, D equals M over V, then plug in our numbers. 15 grams is for mass, 10 milliliters for the volume, and when I divide it out, I get 1.5 grams per milliliter. Notice it is grams per milliliter. It's a combination of those two units in order to form the unit for density. It's always important to make sure that we grab the correct units when we write something down. If this was a density of a solid object, it would be grams per centimeter cubed instead, because remember, milliliters is referring to a liquid or a gas. Moving on to the next one, you need to know the basic SI or System International units for length, mass, volume, temperature, and time. Take a look at this table here. You can see that length is the meter, which is abbreviated M. Mass is kilogram, abbreviated kg. Volume is cubic meter, or meters, or M to the third power. Temperature is in Kelvin, which is a capital K, and time is in second, which is abbreviated S. Of course, with any of those, we can also use other variations on those based on the metric system of changing between the powers of 10. So for example, a kilogram, while it's the base unit for mass, we can also measure in grams, milligrams, etc. Same thing for meters, cubic meters. The degrees Kelvin can also go to degrees Celsius, and seconds, of course, we have hours, minutes, days, years, etc. So let's take a look at reading some measurements. There are actually three types you need to be very familiar with, and that's measuring with a ruler, a graduated cylinder, and a triple beam balance. We're going to start with the ruler today. And if you take a look here, I've got a picture of a ruler that's drawn on the screen. And if you look at it, each one of those lines, the little lines there, represent 1 millimeter. That's why it says the mm there. Now, when we actually break it down then for the spots between the large numbers then, between the 2 and the 3, we can see those are centimeters. Of course, on the bottom side of this ruler, it's meant for use in America, so it also includes inches down there. But we're going to ignore the inches side. So let's take a look at an example here, and we have a crayon that we can put next to it. And when we put the crayon down, we need to line it up at the edge, and you can see it's already lined up nice and even down at the 0. So now we can read our measurement down near the 5 mark. If I draw a straight line down into the ruler itself, you can see it actually isn't quite on the 5.5 mark. It's actually just a little bit over. And we need to estimate that little amount over because we can estimate between the lines. And so in this case, it is 5.52 centimeters is the correct measurement. Now, obviously, you could also say it was 5.51, 5.54. You could be a little bit of a range there for that last decimal place. On the test, you need to pick out the one that's the most correct. And I can tell you, it's not going to be anything that's going to be too confusing for as far as telling which one is the correct one. Let's take a look at another example here, looking at the graduated cylinder. Now, here's a picture of a graduated cylinder. I've removed the bottom part of it, so you're only seeing the very top where it's measuring at. And you can see it's between the 90 and the 95. So that means that each line is going to represent 1 milliliter. Now, when we measure on a graduated cylinder, we need to read from the bottom of the meniscus, or the smile, on the graduated cylinder. Liquids always have this curve on there. This one's kind of exaggerated right now, so you can easily see it, but there's always a curve, and scientists just agreed to always measure from the bottom. If we draw a straight line across there onto the side, we can see it's not exactly at 91 or at 92. Instead, we're going to say it's around 91.4 milliliters. You could also probably say 91.5 and still be correct. But when you look at that then, you can see that you need to estimate how far it is between those two lines. We can always estimate that last digit, and it's very, very important. The last unit system or last measurement you need to know how to use is, of course, a triple beam balance. You'll get a picture of a triple beam balance, and it'll already been balanced out for you. And when we take a look at it, of course, you're going to first look at the hundreds beam and read off its measurement. In this case, it's 300 grams. Then you're going to read the tens beam and see that it's 70 grams. And then finally read the ones beam, which says 3.34. And if you look carefully on there, and you may want to pause the video to look at this, you can see that it is between the 3 and the 4 tenths mark, and it's about halfway, just a little bit short of halfway, and that's where we got the 3.34 grams. And so when you take a look at that, you then need to, of course, add up all of those numbers. And so when I add them all together, I find the actual mass of the object is 373.34 grams. Now, moving on to the next thing. We need to look at data and be able to find the volume of an irregularly shaped object. When we look at that, we're going to use what's called the displacement method. Here's the instructions that your book gave, which says to fill a graduated cylinder 2/3 with water, place the object in the water, and then subtract the volume of the water alone from the volume of the water plus the object. We're going to look at just a data table instead, though, that this has already been done for us. And we can see that somebody's taken the volume of the water and they had it filled up to about 36.3 milliliters, and then they threw the car in and they got 48.2 milliliters. So we need to set up our subtraction problem where we take 48.2 minus 36.3 and find that it's 11.9 milliliters. But you got to hold on for a second and check, does milliliters make sense? Because a car is a solid object, and you've learned that milliliters are for representing liquids, while centimeter cubed is used for a solid. So in this case, we need to use a conversion factor of 1 milliliter equals 1 centimeter cubed. It's a very convenient factor that we have in the metric system. And so with that, then the actual correct answer is 11.9 centimeters cubed. You need to make sure you think about, does my unit make sense at the same time, especially in a situation like this of measuring the volume of an object. The next thing is what is the difference between mass and weight? This is just looking at the definition. Mass is the measure of the amount of matter in an object, while weight measures the force of gravity acting on an object. So for example, mass is always constant for an object. It does not make a difference where we're at, while weight can change depending on gravity. So if I was to go to the moon and measure my mass, it would be the exact same as it is on Earth. But if I measured my weight, it would be significantly less because there's less gravity. Moving on then, what is the difference between precision and accuracy? Precision, or actually we'll start with accuracy, is how close a measurement is to its true or accepted value, while precision is referring to how close a group of measurements are to each other. We have a table here we can see of a dartboard, and we can see the combination of accurate and precise, inaccurate and precise, imprecise and accurate, and inaccurate and imprecise. Typically, if we want to be accurate and precise, that's an ideal situation, of course, where we have the correct answer and we get the same correct answer over and over again. An easier one to fix if you are going to not be both accurate and precise would of course be precise, because you hit the same spot, so that means you can make just an adjustment to get to be accurate. Imprecise though causes issues because you get that scatter across the entire board, and so we want to make sure that we get our data nice and closely together. It's important to be able to know these differences and which ones you want to actually try to attain. Now the next thing then is, given a list of measurements, find the mean, median, and mode. All three of these of course are math terms that we've been looking at. The mean is the numerical average of a set of data. The median, which is also means to add up the numbers, divide the sum, or the answers from adding them up, by the number of items you added. So let's take a look at an example of some data here. I have a number of chairs in classrooms, let's say. And I added all the numbers up and found that the sum was 201. I'm then going to take that and divide it by the number of numbers there were, which is 7. So I have 201 divided by 7, and I find out my average is 28.7. Now let's take a look at median. Median says it's the middle number of a set of data. So to find that, you're going to list all the numbers in order from least to greatest. So we'll take our data set here and use that. Before I do that though, I forgot the middle number is the median. If there are two middle numbers though, remember you have to add them together and divide by 2, or basically take the average of those two numbers. So here's our set of data again, the same one from before. I'm going to put them in order here, and then I'm going to go through and cross out one from the beginning and one from the end, all the way until I get to the very center, and I find out then that the median number is, of course, 28. And so that's why I would write down or bubble in for my answer. The last of the multiple choice things is looking at the mode. And mode is just referring to the number that appears the most often in a list of numbers. And this one's pretty easy to figure out. You look at the list of numbers, you figure out which one occurs more often, and you write it down. In this case, it's 30. Now let's take a look at the constructed response questions. I'm just going to read over the response that's written down on there. It's actually a very good representation of these questions. For number one, you're going to be expected to take the given information and will be required to put the data into a data table. Your score will be based on having your data with the correct units, the data table labeled, and the information in the correct spot. So essentially you're going to get some information and have to put it into a data table. The table's already pre-drawn, you just have to fill it in with all the correct information. The second set of questions is actually going to be looking at you writing a set of procedures like you've done in your science notebook. You'll be given two options to write them on, and your score will be based on if you have all the materials listed, the steps to the procedures are numbered, and there are no obvious steps missing and only one task per step, which that should all sound extremely familiar to you because it matches what we've been doing in our investigations. So you're just going to be expected to do the same thing that you've been doing all this time. On two simple procedures, it's not going to be anything you have to be too worried about knowing how to do. You've probably done both in your life. The last thing, I want to just go over it again because it's so important, is how to study for a major test. Remember, early and often is always the best way, and the biggest thing, study with someone. Have a parent or a friend quiz you on the different things. Of course, if you have questions, you can jump onto My Big Campus or ask them in class. Good luck on studying for the test and look forward to seeing how well you do.